The Korean peninsula has a language of its own. It speaks in radar tracks and radio silences, and those who have learned to listen to it can feel a sentence forming before the first word is spoken. At 5:11 a.m., the sentence had already begun. The RC-135S Cobra Ball reconnaissance aircraft assigned to collect ballistic missile optical and radar data had been on station over the Sea of Japan for 3 hours and 40 minutes, holding a northern orbit that kept it in international airspace while its specialized sensor arrays watched the northern half of the peninsula for the specific infrared signatures that preceded ballistic events. The crew had been briefed on elevated collection priorities 22 hours earlier, when satellite imagery had identified unusual vehicle movement at 2 known North Korean missile support facilities north of Pyongyang. The movement pattern was not the kind that preceded a routine maintenance cycle. It was the kind that preceded something being made ready. They had been waiting. At 5:11 a.m., the waiting ended in a way that the pre-mission briefing had not specifically anticipated. The first radar contact appeared not from the north, where the ballistic threat had been assessed, but from the northwest. A single large return, altitude 31,000 feet, speed approximately 420 knots, bearing 095, emerging from the coast of North Korea on a flight path that placed it over the Yellow Sea on a heading that, if maintained, would carry it southeast along the general axis of the demilitarized zone before turning northeast over the peninsula's eastern coastline toward the Sea of Japan. The return was large, not fighter jet large, but large in the way of an aircraft whose airframe was designed to carry very heavy things over very long distances. The contact was non-radiating. No IFF. No transponder. Nothing that would identify it to any civil or military air traffic control system. The E-8 Sea Joint Stars aircraft orbiting 40 miles south of the contact characterized the return at 5:12 a.m. The radar cross-section profile and the flight characteristics, the specific combination of speed, altitude, cruise configuration, and airframe size, were consistent with the Tupolev 16 derivative operating in the nuclear-capable bomber role. North Korea operated a small number of these airframes, maintained through a decades-long program of reverse engineering and cannibalizing Soviet-era components that Western analysts had repeatedly assessed as unsustainable, and that had repeatedly continued to sustain itself despite those assessments. The aircraft was old. Its systems were old. Its navigation was old. None of those facts made the warhead it was capable of carrying any less functional. The duty officer at Osan Air Base received the Joint Stars characterization at 5:13 a.m. and activated the Theater Alert Protocol in 31 seconds, a response time that reflected both the professionalism of the watch team and the specific gravity of a radar return that matched a nuclear-capable platform departing North Korean airspace without filing a flight plan, without broadcasting any identification, and without making any radio transmission on any monitored frequency. The alert protocol generated 2 immediate outputs. The first was an OPREP-3 Pinnacle report transmitted to Pacific Command, Strategic Command, and the National Military Command Center in Washington, the specific reporting chain that activates when events in a theater have potential strategic-level implications. The second was the launch authorization for the 2 F-16Cs sitting on 5-minute alert at Osan, engines cold, pilots in the squadron ready room, who had been briefed on exactly this contingency and who had been waiting for it, with the specific patience of people who hope they will never be needed and know that their value depends entirely on being ready when they are. The pilots were in their cockpits at 5:14 a.m. The first F-16C was airborne at 5:16 a.m. and 40 seconds. The second followed at 5:17 a.m. and 8 seconds. Both aircraft climbed northwest immediately, pushing toward the intercept vector that the Joint Stars data link was already computing and transmitting. The flight lead, a pilot with 9 years in the F-16 community and 2 prior Korea deployments, had the contact on his radar at 5:18 a.m. at a range of 61 nautical miles. The return was clean and stable. The contact was not maneuvering. It was flying its planned route with the unhurried confidence of a platform that either did not know it was being intercepted or did not care, and in either case was continuing on its heading without any apparent concern for the F-16s climbing toward it from the south. At 5:19 a.m., 2 additional contacts appeared. They materialized from the North Korean coast 14 nautical miles behind the bomber contact, climbing fast, afterburner signatures briefly visible to the Joint Stars thermal array before altitude and range reduced the contrast. MiG-29s. The assessment came from the Joint Stars at 5:19 a.m. and 40 seconds, based on radar cross-section and acceleration profile. 2 of them, climbing through 18,000 feet and accelerating toward the bomber's position on a vector that was clearly designed to place them in a close escort geometry. Not ahead of the bomber, not to the sides in a standard combat air patrol offset, but directly behind it and climbing to its altitude on a trajectory that would put them between the bomber and any intercept approach from the south or east. The MiGs were not there to escort the bomber in the conventional sense. They were there to place themselves between the bomber and the F-16s. They were the shield layer. The bomber was the statement. And whoever had planned this operation had understood that a statement made without a shield is merely an offering. The F-16 flight lead processed the geometry in the time it takes an experienced pilot to read a data link display and concluded, in that same moment, that the intercept he had launched to execute had just become a materially different problem than the one described in the alert brief. The brief had covered a single non-compliant aircraft requiring visual identification and potential escort out of restricted airspace. It had not covered a formation that included dedicated fighter cover positioned between the intercept aircraft and the asset being intercepted. 2 MiG-29s behind a nuclear-capable bomber, climbing to altitude in international airspace in the pre-dawn hours over the Yellow Sea, was not a scenario from the standard playbook. It was a scenario from the part of the playbook that exists in contingency planning documents that most people in the theater never need to read. He reported the updated geometry to Osan at 5:20 a.m. and received acknowledgement. He did not receive new orders. He continued the intercept. At 5:21 a.m., the bomber contact altered its heading. The new bearing was 098, a small change, approximately 8 degrees southeast of the original track, but a change that, applied over the bomber's remaining projected flight path, would bring it closer to the South Korean coastline than the original track had suggested. Not into South Korean airspace, not across the military demarcation line, which ran through the DMZ at the peninsula's center, but closer. Deliberately, measurably, documentably closer. The MiGs accelerated at 5:21 a.m. and 30 seconds, reaching the bomber's altitude and settling into their escort position with a precision that confirmed what the geometry had already implied. This formation had flown this configuration before. The spacing between the MiGs and the bomber, the altitude relationship, the offset angle, these were not improvised. They had been rehearsed. Someone had practiced this flight profile in training until the execution was smooth, and the smoothness of the execution at 5:21 a.m. over the Yellow Sea was, in its own right, a piece of information that the RC-135S to the northeast was recording with interest. The Joint Stars transmitted a formation geometry update at 5:22 a.m. 3-ship formation. Bomber at 31,000 feet. MiG escorts at 30,500 feet, 1.2 nautical miles astern, 0.4 nautical miles lateral offset, 1 left and 1 right. The formation was flying in a configuration that maximized the MiG's ability to respond to a threat from below or from the south while maintaining the visual and radar coverage overlap necessary to ensure no intercept aircraft could approach the bomber from any direction without first entering the MiG's sensor envelope. It was a professionally designed defensive formation. The people who had designed it had thought carefully about the geometry of the threat they expected. The F-16 flight lead reached the formation's radar range at 5:23 a.m. His APG-68 radar resolved all three contacts at 47 nautical miles, the bomber's large, stable return, and the two smaller, slightly faster returns of the MiGs sitting behind it. He called the contact assessment to Osan, confirmed his intercept geometry, and began computing his approach vector. The standard approach to a non-compliant aircraft in this airspace was from the left side, climbing to formation altitude, positioning to the bomber's 7 o'clock to conduct a visual identification pass. That approach vector placed the F-16 on a path that would require it to pass within 1.1 nautical miles of the left side MiG escort. 1.1 nautical miles was within visual range. It was within guns range. It was within short-range missile range. It was, in the specific technical sense, inside the engagement envelope of an aircraft whose pilot had not communicated any intentions and whose government had not provided any explanation for the formation's presence in this airspace at this hour. The flight lead reported the approach geometry conflict to Osan at 5:24 a.m. He stated the tactical problem in precise, factual language that did not editorialize but was completely unambiguous about its implications. He then awaited guidance while continuing to close the range at a speed that was going to force a decision in approximately 90 seconds, regardless of what the guidance said. The guidance arrived at 5:25 a.m. and 12 seconds, 72 seconds after the request. It directed the F-16 section to conduct the visual identification pass, maintain minimum safe separation from the escort aircraft, avoid any action that could be characterized as aggressive maneuvering, and ensure all weapon systems were confirmed safe throughout the approach. The guidance did not address what to do if the MiGs maneuvered to deny the approach. That scenario existed in the contingency planning documents. It had not been addressed in 72 seconds of staffing. The flight lead acknowledged and continued. His wingman moved to a trail position that placed him 1.8 nautical miles behind and 2,000 feet below the lead, a position from which he could observe the approach without being in the MiG's immediate reaction envelope, and from which he could respond to a developing situation without first having to reposition through a geometry that might be actively contested. At 5:26 a.m., the left side MiG altered its position. It moved forward. Not dramatically, not in the kind of aggressive repositioning that would register as an unambiguous hostile act, but forward and slightly outward, expanding its offset from the bomber and placing itself in a position that now sat directly between the approaching F-16 and the bomber's left side. The movement was 0.3 nautical miles forward and 0.15 nautical miles outward. Precise. Measured. Exactly sufficient to occupy the airspace that the F-16's approach vector required. The right side MiG did not move. It held its position. The flight lead registered the repositioning at 5:26 a.m. and 19 seconds. He processed it for 4 seconds. 4 seconds of the kind of focused, crystalline thinking that experienced combat pilots describe as the moment when everything that is not immediately relevant becomes silent, and everything that is relevant becomes very loud. The MiG had moved to deny his approach vector. It had not maneuvered aggressively. It had not illuminated a targeting radar. It had not transmitted anything. It had simply occupied the airspace he needed. Politely, professionally, and with complete effectiveness. He had 3 options. He could attempt the approach through the MiG's new position, which required passing within minimum safe separation of an aircraft that had just demonstrated it was willing to maneuver to contest his approach. He could abort the visual identification pass and report to Osan that the formation had actively, if passively, denied the approach. Or he could reposition to a different approach vector and assess whether the MiGs would contest it as well. He chose the third option because it would produce the most information, and information was what the situation most needed. He altered his heading 14 degrees north, computing a new approach vector that would take him to the bomber's right side instead of the left. The repositioning took 40 seconds. At 5:27 a.m., he was established on a new approach vector aimed at the bomber's 5 o'clock from the right side, at a range of 22 nautical miles. The right side MiG moved forward at 5:27 a.m. and 11 seconds. Same distance. Same precision. Same directional purpose. It occupied the airspace on the bomber's right side that the revised approach vector required, with the same measured, non-aggressive, completely effective repositioning that the left side MiG had executed 62 seconds earlier. The MiG pilots were apparently briefed on the standard visual identification approach vectors. They had prepared a repositioning response for each of them. The flight lead reported the second denial to OSAN at 5:27 a.m. and 40 seconds. He stated it plainly. Both standard approach vectors had been actively denied by the escort aircraft through repositioning maneuvers. He had not been threatened. He had not been illuminated by a targeting radar. He had been blocked, professionally, efficiently, and completely, by pilots who knew exactly what they were doing and had prepared to do exactly this. The situation had reached a threshold that the original alert brief had not addressed, and that the 72-second guidance response had also not addressed. The bomber was continuing on its heading, now at a range of 38 nautical miles from the closest point of South Korean territorial airspace. The MiGs were holding their blocking positions. The F-16s were holding their current geometry, fuel state beginning to become a planning factor after 31 minutes of high-power intercept profile flight. At 5:29 a.m., the RC-135S to the northeast transmitted a signals intelligence update that changed the operational picture in a way that none of the aircraft in the formation had any immediate visibility into. The North Korean bomber was radiating. Not a navigation radar. Not a communication system. A specific emission on a frequency band that the RC-135S's collection system characterized within 8 seconds of first detection. A targeting or weapon system emission consistent with a fire control or delivery system in an active or standby mode. The emission was intermittent, 6 seconds on, variable interval off, and it was on a frequency that had appeared in North Korean nuclear weapons program technical intelligence only 4 times in the past 7 years, each time associated with a system test or a demonstrated capability event. The RC-135S transmitted the characterization to Pacific Command, Strategic Command, and OSAN simultaneously at 5:29 a.m. and 44 seconds. The transmission was classified at the highest available level. At OSAN, it reached the duty officer at 5:30 a.m. and generated a response that arrived at the F-16 flight lead at 5:31 a.m. and 22 seconds, the fastest guidance transmission the watch team had produced in any drill or actual event in the preceding 18 months. The new guidance directed the F-16 section to immediately position to visual range of the bomber formation, photograph the bomber's external configuration with the targeting pod, and transmit the imagery immediately. It did not address the MiG blocking problem. It did not need to. The imagery requirement created an imperative that superseded the approach vector considerations, and the flight lead understood the implication. The blocking problem was now his problem to solve. He solved it by not attempting a standard approach. Instead of approaching from the bomber's beam or rear quarter along any of the vectors the MiGs had anticipated and pre-positioned to deny, he pushed his throttle to full military power, climbed 4,000 feet above the formation, and executed a high-speed overhead pass that placed him directly above the bomber's flight path, looking straight down through his targeting pod at the bomber's upper fuselage and wing surfaces. The pass took 11 seconds. The MiGs could not occupy the airspace directly above the bomber without creating a collision hazard with the bomber itself. The geometry of the blocking problem did not extend to the vertical dimension. It was a solution that existed in the space between the rules that had been anticipated and the rules that had not. The flight lead found it because he had 11 years in the F-16 and an understanding of 3-dimensional airspace geometry that is not written in any training manual but exists in the specific, accumulated spatial intelligence of a pilot who has spent thousands of hours thinking in 3 dimensions. The targeting pod imagery captured at 5:32 a.m. showed the bomber's upper surface in sufficient resolution for the weapon's configuration analysis that the intelligence analysts at Osan began the moment the transmission arrived. The assessment took 8 minutes. The conclusion was transmitted at 5:40 a.m., external stores configuration consistent with a gravity weapon of a class and size documented in the North Korean nuclear delivery program. The weapon appeared to be inert. No arming indicators visible on the external configuration, no active safety system in a pre-release state. But it was there. The airframe was carrying it. And the airframe was over the Yellow Sea with MiG escorts and an intermittent targeting system emission that had now been recorded by the RC-135S for 11 consecutive minutes. The bomber altered course at 5:41 a.m. The new heading was 350, northwest, back toward the North Korean coast. The turn was gradual and wide, the kind executed by a large, heavy aircraft that does not maneuver quickly, and it committed the formation to a return track that would take them back across the North Korean coastline in approximately 18 minutes at current speed. The MiGs adjusted their escort geometry smoothly to accommodate the turn, repositioning with the same rehearsed precision they had demonstrated throughout the engagement. The F-16 flight lead followed the formation through the turn at a range of 4 nautical miles, maintaining his trailing position until the formation had committed fully to the return heading and the geometry left no tactical ambiguity about its intentions. He then broke off and transmitted the formation's course, speed, and heading to Osan. He noted the fuel state, 28% remaining, sufficient for the return to Osan with adequate reserve, but not sufficient for extended further intercept operations. He requested tanker support for the withdrawal phase and received confirmation that AKC-135 was already repositioning to a refueling track. At 5:44 a.m., the North Korean formation crossed back into North Korean airspace. The bomber's targeting system emission, which had been intermittent since 5:29 a.m., went continuous for 40 seconds at 5:43 a.m. as the formation approached the coastline, then went silent as the aircraft crossed the 12 nautical mile limit. The RC-135S recorded the final emission sequence and immediately transmitted it to the analysis queue. The engagement was over. It had lasted 33 minutes from the first radar contact to the formation's return to North Korean airspace. In those 33 minutes, no weapon had been employed, no hostile act had been committed by any party in the legal sense that international aviation law would recognize, and no aircraft had crossed any line that a formal diplomatic protest could specifically identify as a violation. The North Korean formation had flown in international airspace. The F-16s had flown in international airspace. The MiGs had repositioned within that same international airspace. The RC-135S had collected signals intelligence in international airspace. Everything that had occurred was technically, legally, diplomatically ambiguous. Everything that had occurred was also operationally and strategically unambiguous to anyone with access to the full picture. The after-action documentation was extensive. F-16 targeting pod imagery of a nuclear-capable bomber carrying external stores in a delivery configuration. Collected. RC-135S characterization of an active targeting system emission on a frequency associated with North Korean nuclear weapons delivery. Collected. Documentation of a pre-planned, rehearsed 2-ship MiG blocking maneuver designed to deny standard visual identification approach vectors. Collected. Flight profile, formation geometry, and mission timing consistent with a demonstration operation rather than an offensive one. Assessed. Probability that the emission was associated with an active delivery intent versus a deliberate technical demonstration. Assessed at below 15%. What was assessed at above 85% was the conclusion that the operation had been planned, rehearsed, and executed to communicate a specific message using the physical presence of a nuclear-capable airframe in international airspace with an active weapons system emission that the North Korean planning team had assessed would be collected by the RC-135S that was known to be on station. They had not tried to avoid the collection platform. They had flown toward it. The message was the collection. The collection was the message. The F-16 flight lead completed his debrief at 7:15 a.m. He had been awake for 26 hours. The debrief lasted 50 minutes and covered every element of the engagement with the thorough precision that the situation required. At its conclusion, the intelligence officer conducting the debrief paused for a moment before closing his notebook and said nothing for 3 seconds. The specific silence of someone who has just finished building a picture and is sitting with what it shows. The flight lead understood the silence. He had been sitting with it for 2 hours. Outside the debrief room, the Korean peninsula was beginning its morning. The light arriving over the eastern mountains in the particular quality it had at this latitude in this season, cold and clean and without sentiment. The DMZ ran its invisible line across the peninsula's waist, marked on the ground by fences and watchtowers and the accumulated weight of 70 years of armed suspension. Above it, the sky was empty and neutral, as it always appeared from a distance, as it always was not. The numbers: 1 nuclear-capable bomber, 2 MiG-29 escorts, 33 minutes over international airspace, 0 weapons employed, 0 airspace violated, 0 diplomatic incidents formally logged, 2 F-16s, 11 seconds of targeting pod imagery, 11 minutes of active targeting system emission recorded by the RC-135S, 1 external stores configuration documented in sufficient resolution for weapons analysis, 0 lines crossed, every line moved. That is how it works in the airspace above the 38th parallel, where the language is radar tracks and positioning maneuvers and the vocabulary has no word for accidental. Every movement is chosen. Every emission is deliberate. Every second of collection is a sentence in a conversation that has been ongoing for 70 years and that will continue in the pre-dawn hours over the Yellow Sea by pilots who do not speak to each other and do not need to. The sky over the Korean peninsula holds everything and reveals nothing. The record lives in the people who flew through it, and in the sensors that were watching, and in the quiet offices where analysts spend their mornings building understanding from signals that were never meant to be misunderstood.